Find the point on the parabola y squared equals 2x. That is closest to the point 1, 4. All right, let's look at what this looks like. I'm going to do this on decimals. Okay, yeah. Okay, so we know that this graph kind of looks like this. We have this point here. The question is, which point on this parabola is going to give me the closest distance? Okay, this point is 1, 4. Somewhere on this parabola, we call that just xy. So we want the closest distance. Can you think of a way to figure out a distance between 2 points?
They have the same slope.
Not same slope. How do you find the distance between 2 points?
y2 minus 1, 1. Plus x2 minus x.
Ooh, so close. y2 minus y1 and then... Huh? Yeah, squared. Okay.
Squared plus x2 minus x1, and then the whole thing.
Oh, square first again. And then
the whole thing is to the
1/2.
1/2.
Yeah. So this is the distance formula. So to find the distance between 2 points, we use the distance formula. So the question is, how do I find the point that is closest to this point? Closest to this point, what are they talking about? They want maximum or minimum? Maximum distance or minimum distance?
Minimum.
Minimum. Okay, they want the minimum distance between these two. That means we're going to have to take the derivative of d and then find the minimum. Well, like I said, you always have two equations, and then you're going to have to do some substitution, right? So I only have one equation here. Where's my second equation? Huh? Y squared equals 2x. Yeah, so in the original parabola. Y squared equals 2x. So we're going to have to do some substitution into the distance formula. That way we can take the derivative and solve it. You're not looking forward to this, huh? Okay, well, we got to solve that. Y squared equals 2x. What should I do to substitute?
X equals y squared.
Yeah, x equals y squared over 2. All right, so distance formula now becomes, I got to put some numbers in my distance formula, right? I have all these y1, y2s. I'm going to make the 2's the actual point. So 4 minus y plus 1 minus x. And that's all squared. Okay, x is equal to y squared over 2. So that is 4 minus y squared plus 1 minus y squared over 2 squared. Okay, I need to take the derivative of this one. That's horrible. So here's what the textbook says as a trick. They said, just square everything. All right, so this is where we stopped last time. I don't know if you remember. So that was the one where you had a man who is going to go across the river that is 3 kilometers wide, and he wants to go down to a point that is 8 kilometers downstream. He has the option of rolling over first and then run to the point, or he can roll straight to the point, or he can go somewhere in between and then run. And then we said to do that, we gotta find how far is he gonna roll and how far is he gonna run. We said the amount that he is going to row has to do with this diagonal. And that diagonal is, this is 3, so then this is something, so some y. So this diagonal that he's going to row is square root of 3 squared plus y squared. Plus, how much he's actually going to run. The amount he's going to run is going to be 8 minus y, because it's just the leftover of how far he rowed. So that is plus 8 minus y. And then we said that they are trying to minimize time, and since we know speed is equal to distance over time, time is the same as distance over speed. So if we want to figure, so this is the distance. If we want to figure out the time, we have to take each distance. So I'm going to simplify that, 9 plus y squared, divided by the speed that he's going to do that. Okay, so he's going to roll across, which is the square root 9 plus y squared. And he rolls across at 6 kilometers per hour. So that is divided by 6. So distance divided by time, speed is time. Okay, plus 8 minus y, which is how far he's gonna run, divided by 8. Now we need to find the derivative so we can minimize time. All right, go ahead and take the derivative. Like for example, what I would do is change this to 1/6 and then 9 plus y squared to the 1/2. And then I would change this to 1 minus 1/8 times y. That way it's easy to take derivative. All right, let's do that on the side. Okay. Okay, 1/6 times 1/2 times 9 plus y squared to the negative 1/2 times 2y minus 1/8. Right? So that cancels. That is y over 6. 9 plus y squared to the 1/2 minus 1/8. Yes?
Yes.
Okay, and then we want to just multiply, try to get them to have the same denominator, right? The least common denominator is 24. So I'm going to multiply 4 over 4 here. 24 and then that square root thing. Okay, that is 4y minus 4, 9 plus y squared to the 1/2. In the denominator, I have I'm sorry, not 4. Over there, 3. 24, 9 plus y squared to the 1/2. Sorry, that should be a 3. All right, and then just make the top equal 0, the bottom equal 0. And solve. All right, making the numerator equal to 0, 4y minus 3 times 9 plus y squared to the 1/2 is equal to 0. So move 4y to the other side, negative 3 times 9 plus y squared to the 1/2 is equal to minus 4y. Square both sides. 9 times 9 plus y squared is equal to 16y. I hope I'm still doing, yes. Okay, so this is 81 plus 9y squared. I'm sorry, I forgot a square there. Equals 16y squared. Subtract 9y squared. 81 is equal to 7y squared. Divide by 7. 81 over 7 is equal to y squared. So y is equal to 9 over square root 7. Plus minus, but we only want the positive distance. We can do a sign chart, but that has to be the answer. So he needs to run this much up, 9 over square root 7 up, or roll to that point and then run up. All right, we're gonna do one more. I think every time we do some kind of geometric ones, everyone gets stuck on the homework, so let's do this one. Find the area of the largest rectangle that can be inscribed in a semicircle of radius r. Semicircle. Largest area of a rectangle, so some rectangle, and it has a radius r. What is the biggest area? All right, please, I'm gonna give you some points. This is x, this is y. R is obviously, r squared is x squared plus y squared. So I want you to write an equation of area. Okay, what do you guys write for the area of this rectangle? 2x times y. Well, we gotta make sure that everything has just one variable. We have x and we have y, so we need to find y. Y squared is r squared minus x squared, right? And then y is square root of r squared minus x squared. So that is 2x times square root of r squared minus x squared. Again, r doesn't matter. It's not a variable. R is just a number in this question. All right, go ahead and find out what is the largest area. All right, so let me just give you the answer. X is equal to square root 2 over 2r. So then the largest area is r squared.